In this video, we shall be looking at probability. So let's take some examples. The question says, Sarah is deciding which course she wants to take in her next college semester. The probability that she will enroll in an algebra course is 0.3, and the probability that she will enroll in a biology course is 0.7. The probability that she will enroll in an algebra course given that she enroll in a biology course is 0.4. Question A. What is the probability that she will enroll in both an algebra course and a biology course? Question B. What is the probability that she will enroll in an algebra course or a biology course? Question C. Are the two events independent? Question D. Are the two events mutually exclusive? Solution. Let's start by putting down the data we have from the question. The probability that she selects an algebra course is PA, let's use A for algebra, is equals to 0.3, right? The probability that she enrolls in a biology course, let's use B for biology, is equals to 0.7. Now, the probability that she enrolls in an algebra course given a biology course, algebra given biology, is equals to 0.4. So these are the information we have from the question. So let's solve question A. Question A says, what is the probability that she will enroll in both algebra course and biology course? So we have the probability she will enroll in algebra and biology, and that is equals to the probability of A given B times the probability of B. So we know the probability of A given B is 0.4 and the probability of B is 0.7. When you multiply 0.4 by 0.7, what you have is 0.28, and this is equivalent to 28% when you multiply this by 100. So there's a 28% chance of she enrolling in algebra and biology course. So B says, what is the probability that she enrolls in an algebra course or a biology course? So the probability she enrolls in algebra or biology course based on addition rule is equal to the probability of A plus the probability of B minus the probability of A and B. So we know the probability of A is 0.3 plus the probability of B is 0.7 minus the probability of A and B is 0.28. Now the probability of 0.3 plus the probability of 0.7 is equal to probability of 1.0 minus 0.28. Therefore, what we'll have is the probability of 0.72. When you multiply this by 100, you have 72%. So there's a 72% chance that she will enroll in algebra or biology course. Let's take question C. Question C says, are the two events independent? So this is the requirement for an event to be independent. We have the probability of A given B must be equal to the probability of A for the event to be what? Independent. So the probability of A given B, we know that to be what? 0.4, and the probability of A, we know that to be 0.3. So therefore, since the probability of A given B is not equal to the probability of A, these events are not independent. Now let's look at D. D says, are the two events mutually exclusive? Now for an event to be mutually exclusive, the probability of event A and B must be equal to 0. And in this case, event A and B is equal to 0.28. Therefore, the two events are not mutually exclusive. Question says, a jar contains 7 red marbles, 6 green marbles, 5 blue marbles, and 2 yellow marbles. What is the probability of selecting A green marble, B, a blue marble, C, green or yellow marble, D, red, then blue with replacement, E, red, then blue without replacement, F, red and blue without replacement? Solution. let's put down first the information we have from the question. So from the question, we know that we have 7 red marbles. For green, we have 6 green marbles. For blue, we have 5 blue marbles. And yellow, we have 2 yellow marbles. In total, we have 7 plus 6 plus 5 plus 2. We have 20 marbles in the jar. Question A. It says, what is the probability of selecting a green marble? So the probability of selecting a green marble is equals to, we have 6 green marbles divided by the total marble in the jar is 20. So both the numerator and the denominator is divisible by 2. So 2 divided by 6, we have 3. 2 divided by 20, we have 10. So 3 divided by 10, we have 0.3. When you multiply this by 100, you have 30%. So there's a 30% chance of selecting a green marble from the jar. So let's say question B. It says, what is the probability of selecting a blue marble? So the probability of selecting a blue marble, this is equals to, we have 5 blue marbles and a total of 20 marbles in the jar. This is divisible by 5. 5 divided by 5, we have 1. 5 divided by 20, we have 4. 1 divided by 4, we have 0.25. Multiplying this by 100, we have 25% chance of selecting a blue marble. So the probability of not selecting a blue marble is equals to 1 minus the probability of selecting a blue marble. And this is going to be 1 minus 0.25, which is going to be equals to 0.75. And this is going to be, when you multiply this by 100, you have a 75% chance of not selecting a blue marble. Now let's look at question C. C says, what is the probability of selecting a green or yellow marble? Whenever you hear the word or, it implies addition, and when you hear the word and, it implies multiplication. So the probability of selecting a green or yellow marble, so this is going to be probability of selecting a green and then yellow marble. So we know that the probability of selecting a green marble, for green we have 6 all over 20, and then or this plus, and then for yellow marble we have 2 yellow marble all over 20 marbles in the jar. So we know this, we can say bring down 20, so we have 6 plus 2. 6 plus 2, we have 8 all over 20. This is divisible by 4. We have 4 divided by 8 is 4. Sorry, 4 divided by 8 is 2, not 4. 2. 4 divided by 20, we have 5. Now, 2 divided by 5 is equals to 0.4. When you multiply this by 100, so there's a 40% chance of selecting a green or yellow marble. Now, question D. Question D says, what is the probability of selecting a red then blue marble with replacement? This is basically an AND statement. The probability of selecting a red then blue marble with replacement. Now the order matters. You are selecting a red first, then blue marble. Now the probability of selecting a red marble is 7, and then we have 20 total marbles in the jar. Now multiply by the probability of selecting a blue marble. Since we are replacing it, so the marble we took, we will return it back in the jar. So we have 20 marbles still in the jar. So the probability of selecting a blue marble, we have 5 blue marbles in the jar and then 20 marbles in total in the jar. Put 7 all over 20, multiply by, when you divide 5 divided by 5, you know you have 1 all over 5 divided by 20, we have 4. Right? So this is going to be equal to 7 multiplied by 1 is 7 all over 20 multiplied by 4, we have 80. Right? So 80 divided by 7 divided by 80, we have 0.0875. When you multiply this by 100, what you have is going to be 8.75%. So there's 8.75% chance of selecting a red then blue marble with replacement. Let's take question E. What is the probability of selecting a red then blue marble without replacement? This is also an AND statement. So the probability of selecting a red then blue marble. So we know for a red marble we have 7 red marbles and we have 20 marbles in total. Then we have 5 blue marbles. Now in this case there is no replacement, so therefore the one marble you took, there is a total of 19 marbles in the jar because you've taken one marble, so we have 19 marbles. Now we say 7 marbles. For 20 we know that 5 multiplied by 4 is 20. Multiply by, then we have 5 all over 19, right? So 5 will cancel 5. Therefore, what we will be left with is 7 all over 4 multiplied by 1 all over 19. 7 times 1 is equals to 1, and then 4 multiplied by 19 we have 76. So sorry, this is 7, not 1. 7 divided by 76 is equals to 0.09, or let's just put it here. I think this space will accommodate 0.092, right? So when you multiply this by 100, there's a 9.2% chance of selecting a red then blue marble without replacement. For question F, what is the probability of selecting a red and blue marble without replacement? So in this case, the order is not specified. Since the order is not specified, we have the probability of selecting the red, then the blue, or we select the blue, then the red. So therefore, what we'll have now is going to be, so the probability of selecting a red marble will have 7 red marbles in the jar and then 20 marbles total in the jar. Now, it says without replacement. So if you select a red marble, for the blue marble we have 5 blue marbles in the jar, but then we'll have 19 marbles left because we have taken one marble. So we have 19. So, or we could select a blue marble first, a total of 20, then we select a red marble next. So we have 7 all over 19. This is going to be 5 here, we have 1, and with no 5 here, we have 4. So we have 7 all over 4 multiplied by 1 all over 19 plus 5 here, we know it's a 1, and 5 here, we have what, 4. So it's going to be 1 all over 4 multiplied by 7 all over 19. What we'll have now is going to be 7 all over 76, because 7 multiplied by 1 is 7, 4 multiplied by 19 is 76, plus the same thing, 7 all over 76. So we have 76, 7, we have what, 14. When you have 76 all over 14, this is divisible by 2. So you divide by 2, we have 7, divide by 2, we have 38. Now 7 divided by 32, what we have is going to be 0.184. Multiply this by 100, what you have is going to be what? 18.4%. So there's 18.4% chance of selecting a red and blue marble without replacement. That will be all for this video. Thank you so much for watching. Please like, share, subscribe, and hit the notification button.